Hey guys, welcome to day 16, starting a new chapter. So by now you should have read chapter 9, and you might be a little bit confused. I think you will be a little bit confused at the beginning of this chapter, but hopefully over the next few days I will be able to clear some things up for you. Can be a little bit abstract, so just bear with me here, and we're going to see what we can do. So last chapter, we spent a lot of time on Lewis structures. And Lewis structures is this idea that valence electrons pair up to form chemical bonds. We have single bonds, one shared pair. We have double bonds, two shared pairs. And we have triple bonds, three shared pairs. But now we're going to dig into kind of this other theory called the molecular orbital theory. And this is the idea that sometimes electrons don't belong to a single atom or a pair of atoms, but rather the whole molecule. And we're going to look at bonding in a little bit of a different manner here. So, hybridization. A hybrid is when you take something, you take two things and you combine them to make a new thing. For an example, a hybrid automobile. You take a gasoline engine and an electrical motor, you combine them together to make a hybrid. Another example might be dogs. Okay, you take a golden retriever and a poodle and you end up with a golden doodle. So a hybrid is when you take two things that are different and you merge them together to make something that is new. And hybridization is this idea that s orbitals and p orbitals and sometimes d orbitals kind of combine to make these new hybrid orbitals. So they're not s's and they're not p's, but they're sp hybrids. And it's going to be a little confusing at first. I'm going to try to explain things the best I can. You guys are going to make sure you want to watch some of the videos that I tag along with this. Okay, so first of all, when we are talking about covalent bonding, realize we are primarily talking about the nonmetals. And carbon is king. What the heck does that mean? Carbon can hybridize in just about more different ways than any other atom can. So hybridization is this idea of S's and P's and sometimes D's kind of mixing together to make a new orbital, okay? So today we are going to focus on just two types of hybridization. There's actually about 4 or 5 we're going to talk about, but let's kind of keep it simple today. And the first type is sp3 hybridization. Okay, so we know what an s orbital is. It's an area of an electron that can hold 2 electrons, and we know what a p orbital is. P orbitals can hold up to usually 6 electrons per atom. Okay, so if we look at something like methane, methane has a carbon in the middle surrounded by 4 hydrogens. So 4 single bonds, you say, and I agree. Okay, but what's happening with carbon is carbon forms hybrids, okay? So if you look at hydrogen, hydrogen really only has one s orbital. And if we were to do the electron configuration for hydrogen, it would look like this, 1s1. Now, because hydrogen only has one type of orbital, there will be no hybridization for hydrogen. But if we look at carbon, carbon has one core electron, but carbon has 4 valence electrons. And those valence electrons live in these outermost s and p orbitals, okay? So what's going to happen is that these orbitals, these s's and these p's, are going to hybridize. And you kind of notice that I labeled these 3p orbitals, x, y, and z. Those are just your different orientation. X is normally this way. Y is normally up and down, and Z would kind of be your going into the page axis. So we've got these 3 orientations. We've got these 3 orbitals, X, Y, and Z. Okay, so what carbon is going to do in the case of methane is we are going to get 4 hybrids, okay? And these hybrids are going to be hybrids of S's and P's and D's. Now, how many orbitals are combining? Okay, we've got 1 orbital, 2 orbitals, 3 orbitals, and 4 orbitals. And what's going to happen is we are going to end up with 4 new hybrids, okay? And those 4 new hybrids are all going to be the same. Those 4 new hybrids are going to be called SP. I guess I should write them all the same size, SP3 hybrids. So there will be 4 SP3 hybrids, okay? And one of the ways that you can identify something as an sp hybrid is basically look at neighbors plus unshared pairs. And if you look at methane, carbon has 4 neighbors plus 0 unshared pairs, and the sum of that is 4. And if the sum of those numbers is 4, you can say that, hey, this must be 4 new hybrids, and these 4 new hybrids are all going to be sp3 hybrids. I know you're confused. Bear with me here, okay? All right, so carbon is king. Carbon can hybridize many ways, and in the case of methane, these outermost s and p orbitals hybridize to form 4 new hybrids, and those hybrids are called sp3 hybrids. So there is going to be 4 of those, okay? Neighbors plus unshared pairs can give you a clue about hybridization. Okay, I think if we do enough examples, you guys are going to be able to pick up the pattern. You're going to be confused, okay? All right, so let's look at another type of hybridization, okay? And ethylene. So if I were to draw ethylene, okay, we have 2 carbons in the middle, and those carbons are double bonded, and each one of those carbons has 3 neighbors. So if you look at carbon, and both carbons are really the same, we could say that carbon has a 3 plus 0 center atom combination, meaning that carbon has 3 neighbors and carbon has 0 unshared pairs. So let's kind of go back and look at this. All right, so ethylene, C2H4, okay? Carbon has an outermost s orbital. That's your 2s, okay? And it has some p orbitals. It actually has 3 outermost p orbitals, but only 2 of those are going to get involved, okay? So when you hybridized an s orbital with 2 p orbitals, you end up with sp2 hybrids. Now, one of those p orbitals is not going to get hybridized. So we have 3 orbitals that are hybridized, one of the s's and 2 of the p's, but one of those outermost p orbitals is not used, okay? So not all orbitals are hybridized, okay? So in this case, we get a quantity of 3 sp2 hybrids, and the shape of this is going to be trigonal planar. So if you look at my center atom combination, 3 plus 0 equals 3, and that's going to give you a pretty good close as to the type of the hybridization. If the center atom combination adds up to 3, it's going to be sp2 hybridized. Okay, now let's talk about single bonds and double bonds and triple bonds a little bit. Okay, first bonds that are formed between atoms will always be sigma bonds. So a sigma bond is one shared pair of electron. Now there's a couple ways we could look at this. We could look at a simple sigma bond. So we have a hydrogen with another hydrogen, okay? A hydrogen bonding with a hydrogen. When these 2 s orbitals overlap, this is going to be a single bond, and all single bonds are sigma bonds. It's the first bond made between 2 atoms. It's caused by head-on overlapping. If I were to draw this a little bit differently, we could show this s orbital from one hydrogen atom overlapping an s orbital from another hydrogen atom, and we realize that circles or spheres don't have heads, but anytime 2 s orbitals overlap, in this case, this is considered to be a sigma bond, okay? And it's the strongest type of covalent bond, and we're going to talk about another kind here in just a minute, but sometimes it can be p orbitals as well. Okay, so we'll talk about a little bit this in a minute. So the first type of bond is a sigma bond. It's the first bond made between atoms. It's one shared pair of electrons caused by head-on overlapping, and it's the strongest bond, okay? So when we have a carbon-hydrogen bond, in this case, it is going to be a sigma bond, okay? Now, if you look at the carbons, there is a double bond between them. Now, the first bond form is going to be a sigma bond, okay? So if you look at these 2 bonds, we can dissect this a little bit. We could say one of these is going to be a sigma bond, but the other one is going to be a different type of bond, and that bond is going to be a pi bond, okay? Like the Greek letter pi, okay? And a pi bond is formed by p orbitals that overlap side to side. And if I kind of show you this, what if I had a carbon atom here? And this represents a p orbital, okay? This is one p orbital. And we have another carbon atom with a p orbital that has not been hybridized, And when these overlap kind of side by side, this is called a pi bond. So P's get involved in pi's. And this is caused by side overlapping. Okay, and pi bonds are pretty strong, but not quite as strong as sigma bonds, okay? Usually slightly weaker than a sigma bond. So anytime you see a single bond, and we're going to break this molecule down a little bit, all of these single bonds are sigmas. So this is the letter for sigma. So this is a sigma bond, this is a sigma bond, this is a sigma bond, and this is a sigma bond. Now in the middle, we have a double bond. One of those is going to be a sigma bond, and one of those is going to be a pi bond. Let's go back and look at methane again. These are all going to be sigma bonds. Okay, so we've got a sigma bond here, we've got a sigma bond there, we've got a sigma bond there, and a sigma bond there. So all of these bonds are sigma bonds, okay? All right, I know you guys are a little bit confused, but let's go ahead and look at some of the homework that I probably would have assigned. So if you look at hydrogen, how many neighbors plus unshared pairs does oxygen have? Okay, so oxygen is a central atom. Oxygen has two neighbors. Oxygen has two unshared pairs, and the sum of that is 4. So this tells me that oxygen is going to be sp3 hybridized. So if we have 4 orbitals, now 2 of those orbitals are involved in bonding with hydrogen, and 2 of those orbitals just contain non-bonding pairs. So oxygen in the case of water is going to be sp3 hybridized. And if we were to count these lone pairs there and there, it kind of would form a tetrahedron, okay? Let's look at another example. Let's look at formaldehyde. So carbon is our central atom. Carbon has 3 neighbors. Carbon has 0 unshared pairs. The sum of that is 3. If the sum of neighbors and unshared pairs is 3, it is going to be sp2 hybridized. And if it's sp2 hybridized, it's going to be trigonal planar, and the bond angle is going to be about 120 degrees. So when we look at this molecule, carbon forms a sigma bond with one hydrogen. Carbon forms a sigma bond with the other hydrogen. And when we kind of look a little bit closer, so this is going to be a sigma. This is going to be a sigma. One of these is going to be a sigma, and I'm going to erase up here. And one of these is going to be a pi bond. So we've got 3 sigma bonds and 1 pi bond. Let's just do more examples. All right, let's look at carbon tetrafluoride. Okay, carbon is your central atom. Carbon has 4 neighbors plus 0 unshared pairs. The sum is 4. It must be sp3 hybridized. And let's break these bonds down. This one's going to be a sigma. This one, and this one are all going to be sigma bonds. So there are no pi bonds in carbon tetrafluoride. Let's do another one. Nitrogen trifluoride. Okay, nitrogen is the central atom. Nitrogen has 3 neighbors. Nitrogen has 1 unshared pairs. The sum is 4. It must be sp3 hybridized. Okay, and if you were to consider the types of bonds, they are all sigma bonds. Single bonds are always going to be sigma. So we got a sigma bond there, a sigma bond there, and then our third bond with our fluoride is going to be sigma. Now we would say this molecule is trigonal pyramid, but if you consider that this is a hybrid orbital up here, now we would say, including the lone pairs, it would be more of a tetrahedron shape. All right, let's do another one. Oxygen is at the middle. Oxygen has 2 neighbors. Oxygen has 2 unshared pairs. 4, it must be sp3 hybridized, okay? We've got a sigma bond here. We've got a sigma bond there, and no pi bonds. And we would say that this molecule appears to be bent, but if we start to include these unshared pairs, now we can say that it's more tetrahedral in shape. Let's do another one. Boron, 3 neighbors plus 0 unshared pairs. Boron must be sp2 hybridized, okay? All of which are sigma bonds, okay? 2 plus 0 is a type of hybridization we haven't talked about yet. We'll save that for another day. Okay, this one I think we will save for another day as well. So I'm looking through some of these examples. Some of them are beyond the topics that we've talked about today, so we will talk about them a little bit more tomorrow. So guys, I am going to post a screencast, and I'm going to go ahead and tag some other videos. It might be to your benefit to watch those other videos. I know you're confused. I think within a couple of days, things will be cleared up. It can be a little tricky at first. It's not as hard as it sounds. Hybridization, kind of weird, but it's not a big deal. All right, guys, if you have any questions, shoot me an email. Ask me a question on Google Classroom. I miss you guys. I love you guys.